Hello everyone, welcome back to my channel. Today let's go over a premium medium question that I just solved on my own. So I'm super happy about this and I'm very glad that I was able to come up with my own solution to this question without any assistance. So let's go over it and let me show you how I did it. So this is question 3837 called delayed count of equal elements. So you're given an integer array nums and an integer k. Basically, at each position, you want to define for that position how many, basically to the right of the current plus k are equal to the current element. So in this case, for example, k is 1. So if we're on index 0, then, so let's go ahead and draw this out. So if we're on index 0 and k is this, because I plus k has to be less than j, then we're only going to care about everything from this point on, which is just going to be 2 to the n, right? Because I plus k is 1, and it has to be less than, so at least has to be 2. So we're just going to count how many ones are I plus k plus 1 to the right to the end, right? And then we do that for every single position. So for 2, for example, for index 1, we're just going to do the same thing. And in this case, there is no 1 to the right of 2, so the answer is just going to be 0. Answers here is going to be 2 because there are 2 1s to the right of that current 1, right? And then we're just going to do the same thing here. So because I plus k plus 1 is out of bounds, so that's going to be 0, and that's going to be 0 as well, right? Cool. So let's go ahead and code it up. So let's loop from left to right. And then let's start the pointer at I plus k plus 1 to the end. So basically for here, then we're just going to, j is going to go from here to here. And then let's keep track of the counts and an answer. So again, if nums of j is equal to nums of I, then we're going to increment the count. And then we can just append the count and return the result at the end, right? So let's run this, submit it. So you'll notice that this times out because this is an n squared solution. So let me show you exactly how I optimized it because there's definitely a better way to do this. So instead of counting with this nested loop, since we're trying to find how many elements are equal, then why not just keep track of all the elements in a sorted list, right? Because first of all, we know we're only going to be starting at the very least at k plus 1, right? So let's get everything from k plus 1 to the end. And then as we loop here, we're only caring about this one. As we loop here, we're only caring about anything to the out of bounds because this, first of all, there's no 1 to the right of this. And if there was, it would be out of bounds. So that's the case there. So, and then these two are obviously out of bounds. So again, we're only going to care about things 2 decimals, 2 places away for this case. In this case, only 1 decimal away. So we're looking at everything from the right here, for here. We're looking at everything here. And then from here, everything here. Because there's nothing equal to 3 to the right of this 3 at index 2. And then same thing for 1. There is no right of 1. So as we loop through, first of all, let's go ahead and first say after we process the current element, because we're already at I plus k plus 1, which is k is 1, so k would be 2. So we're already processing this, so for the current element. And then we'll discard this. And then as we look here, then we're going to only check for here. So this one plus 2 is actually here. So then let's just say if I plus k plus 1 is less than length of nums, then let's just discard, right? If it's not in there, then it won't remove anything. Then we're just going to remove I plus k plus 1, right? So if we print our current element in our sorted list, you can see that we have exactly the elements to the right that we need. Exactly k plus 1 places away to the right. So then here, because we're trying to find how many elements in that section are equal to this one, let's just find the first element, because this is already a sorted list, right? The first element to the left, we can run a binary search to find the leftmost element equal to 1, and then a binary search to find the rightmost element of 1. So we can just use the bisect left function in nums of in this sorted list, and then the same thing with the bisect right function. So it's going to be find the rightmost element, and that is equal to nums of I, right? And then the value is just going to be that difference in that case, right? Because they're already in sorted order, so if the values are equal, they're already going to be next to each other, right? So then we can just append value and then return answer at the end. So that's going to take this down to n log of n, which is a lot better than n squared. So let's run this and submit it. And there you go, passes all test cases. So again, I'm super happy that I was able to come up with my own solution to this question without any assistance and solve it completely on my own. So that's it for this video, and thank you for watching.